Hi, I'm Nidhi Singhai. I'm an India Internet section student, and I'm going to give demo about my project. My project included the implementation of Programming Assignment 1 and Programming Assignment 2. Programming Assignment 1 is the implementation of classical ciphers, which are substitution cipher, transposition cipher, and product cipher. Programming Assignment 2 is the implementation of RSA crypto systems. So first we'll start with the demo for classical ciphers. This is my folder, and let me first start my executable. So this is the front screen that I get upon the executable. Now we'll just take a look at the files that I'm going to use for the encryption, decryption, and the keys. So I have a folder called files which contains all the text files that I'll be using. So here I have 4 input files. 2 are 1 KB files and one is 2 KB, one is 5 KB. Then I have a subs key file which contains the substitution rule, and then I have a trans key file which contains the transposition rule, and a sample file. Now if you just look at the subs key file, it contains the substitution rule for the complete input character set, which includes small alphabets, capital alphabets, and digits. Now if I go to the trans key file, my trans key file contains a word which is of the length of block size, which means 8 characters. Now, this word will be jumbled and the relative position of the alphabets will be found out with this word. Like rainbows has A is in the second position, so we'll move it to first and all. So let's start with our demo. The first I'll do is we'll do the substitution cipher inscription. So we'll pick up a file which is 1 KB, my substitution key, and here the encryption is done. Retrieved the substitution key, performed encryption using substitution, and my cipher file is present as at file subcipher.txt. Now if we go here, yes, indeed we have the file here, and this is the substitution file that I have. Now let's decrypt the same file. Now we choose decryption, decrypt a file using substitution cipher. I give file ciphertext file slash subs key.txt using the same key. Decrypted file is present at file subsplain.txt. So if we again check here, yes, we have a file here, and the size is the same as the original file, input1.txt. We just check the file, and yes, it is there. Now we do using we'll check transposition cipher now. Clear screen. We encrypt a file using transposition cipher. Now this time we'll use the 2 KB file for our testing, input2.txt. So file slash input2.txt, file slash transkey.txt. It performed the encryption using transposition, and the transposition encrypted file is at location transcipher.txt. Let's check it here. Yes, we have transcipher.txt. Now the transposition rule that we have followed here is the row transposition rule, which means that since our block size is 8 characters, we pick up every 8 characters and we permute it, or we shuffle the characters using the transposition rule, and then we write it to the cipher file. Now we'll try to decrypt the same file. We choose 2 here, 2 for transposition. I choose this file name, file star. We give the transposition key, and transposition decrypted file is at location transorij.txt. We just check it here, and yes, we have it here. and this is my decrypted file. Now, for the product cipher, we'll use the 5 KB file, which is this file. So we encrypt using product cipher. File name is file input5.txt. We first give the substitution key, subskey.txt, file stack transkey.txt, and final encrypted file using product cipher is at prodcipher.txt. So if we check here, yes, prodcipher.txt is here. This is the first substituted and then transposed file. Now we'll decrypt the same file using prod cipher. We give the substitution key, which is file /subskey.txt, key.txt, and the final decrypted file using product, it's at prodtext.txt. Yes, this is the final file. Now we come to the last part, which is the cryptanalysis. In this project, we have done the cryptanalysis using transposition cipher. The cryptanalysis using substitution cipher and product cipher will be taken up as a future work. So we do analyze a file. We choose transposition cipher. We enter the name of the transposition cipher file, which was transcipher.txt. Enter the sample words file. Now we'll just see what our sample words file contains. Here the sample word file contains three words. We have boarding, computer, and security. Now my original file does not contain boarding. So he'll check, the program will check boarding against all the complete file. It won't find it, then it will move to computer, finally to security. So .txt. Now if we just check this part, the sample words are boarding, computer, and security. We find the transposition key. Sample word picked for analysis is boarding. Then sample word picked for, since it didn't find anything, we found computer, and we found the transposition key. We wrote the key to the key file, decrypted using the transposition key. Our key file is present in transcript key.txt, and then here is the plain file. So we'll just check these two. Key.txt contains this. Now if we check, our original key was rainbows. So if we just check and give the numbers to the alphabets, it will come to 50231476 only. Then we open the crypt file, and this is. Now we'll just check a few error handling that we handled here. Mostly if we gave a file and the file does not exist, such kind of error handlings. So suppose I do an encrypt, so the program will simply exit. So suppose I give one and I choose substitution cipher. I give files xyz.txt, files subskey.txt. Now we don't have any xyz file here. So encrypt file, error opening plain text file. So it didn't open the plain text file. So We this shows that we did not have any crashes in the system in case of any errors that we are handling. So this brings us to the end of the demo for classical ciphers. Now the second demo that I'll give is the demo for RSA crypto system. Yeah. So now, in case of RSA crypto system, the first operation, there are three operations basically that are involved again. First is generation of keys, in which we find two prime numbers and we find our encryption and decryption key. And then we encrypt the message, we decrypt the message. So, first we'll start with generate keys. So here we are generating prime number P. Also, if you can see, debugging is turned off. If we want to debug the program, then we just call the executable with the parameter as 1. That will turn on the debugging, and then we can debug using the logs. Now, here, how we are generating random numbers is I've used the GMP multi-precision library for my for this project, and I'm not using the random number generator of GMP because it has a linear congruential property which is not suggested for cryptographic operations. So what I have done is I have used RAND and SRAND, and I have generated 16 random numbers and concatenated all of them, formed a string. With that string, I have created the GMP number, which I'm checking against for primality. And I'm checking primality using Miller-Rabin method. So here, I've added a random delay of approximately 1 second so that I get different numbers and the numbers are not repeated for me. I've had a varied experience with the time that I have seen while generating random numbers. While my best time for generating both the random numbers has been 20 to 26 seconds, the worst has been even 10 minutes. While our numbers are being generated, we'll just have a look at the input file that I'm using. I'm using a 1 KB input file. So we just do. So this is the input file that I'll be using for RSA encryption. Oh, we have generated P already. Now we are generating Q. The way I've performed RSA encryption is the input file that I have. I'm picking up 32 characters in one round and I'm generating a GMP number from those 32 characters. And from the string, I'm creating my GMP number, and then I'm performing the RSA encryption. The result number, I'm adding it to a file. Now, since the file will have multiple such numbers, I'm using space as the delimiter in my file. Also, since the input characters are alphabets mostly, so just to have sync between the input and the output characters, I have just converted the numbers, the digits of the numbers, to corresponding alphabets. So 0 will be converted to A, and B to 1, 1 to B, and so on. Also, at the end of this function, we'll have two prime numbers generated, which is P and Q. Now, just as a verification, what I have done is I have used the GMP inbuilt prime method to check if a number is prime or not. Now, we know that the Miller-Rabin method gives us a number which is most probably prime with a high probability. So the GMP function will return us the same output, saying that the number is most probably a prime number. So we'll just see it in a while. Once the numbers are generated, we can see the verification logs as well. Good. So we have the prime numbers generated here. P was generated earlier. This is Q. Now we are verifying primality using GMP functions. So we are verifying P. So P is most probably a prime number. Then we verify Q. Q is also most probably a prime number. Then we select the encryption key. The encryption key here is this. And then we select the decryption key. Decryption key is this. Now we write private key to the private key.txt. Private key basically consists of our decryption key, and the public key basically consists of the encryption key and n. So since n will be used during decryption also, so the private key.txt will also contain n. So let us just check our files. We have private key.txt. N is this, which is the product of P and Q, the two prime numbers that we found. D is this. We have public key.txt, N is this, and E is this. Now we'll perform the next operation, which is encrypt message. We'll do encrypt message. We'll enter the text file name, which is input.txt. We'll enter the public key file name, which is public key.txt. So reading the encryption keys, then encrypting the message. Location of the ciphertext file is here, and the time taken is 33 milliseconds. We'll just check the ciphertext file. So this is what I was talking about. So this is one number, and I've converted that number into corresponding digits, corresponding alphabets. So like B, D, D, the number would be actually 1, 3, 3 something. And then the space acts as a delimiter between all the encrypted numbers. Now we'll perform decryption using RSA. So our ciphertext file is files, RSA ciphertext. Private key.txt. So reading the decryption key, decrypting the message, location of the decrypted file is RSA plaintext.txt. Time taken is 36 milliseconds. So we'll just do here. We have RSA plaintext.txt, which is our original file. So this brings us to the end of the demo. In case you have any questions or queries regarding the project, kindly mail me at nsinghai@hop.iit.edu. Thank you for listening. Thank you.